Now, with just 2 steps, the image is half the original size. Note that when reassembling the picture, the blue and red chrominance images are rescaled to match the size of the luminance component, with the RGB values being recalculated from luminance, blue chrominance, and red chrominance. And because the luminance changes from pixel to pixel, the recalculated RGB values can change from pixel to pixel as well. The next 2 steps are definitely a little more complicated, and they're called discrete cosine transform, or DCT, and quantization. Together, these 2 steps also remove information, but they do it by exploiting the fact that our eyes aren't good at perceiving high-frequency elements within images. What does that mean? Well, let's take a look at this picture of the woods. Our eyes are great at seeing the edge of a tree or the outline of a rock. But when it comes to focusing on and distinguishing high-frequency color data, such as single blades of grass, individual leaves in a cluster of leaves, or variations in the shadows created by the leaves of a tree, our eyes can't really pick out the details. Furthermore, most nature or landscape photography has portions of the image that are out of focus, and removing high-frequency color variation to create smoother textures is unnoticeable. So then, how does the JPEG algorithm exploit the nuance of the human eye? Well, essentially, the discrete cosine transform and quantization steps go through each section of the image and find areas that have a high frequency of alternating chrominance or luminance. These elements that our eyes aren't able to perceive are then removed.